So I've entered in some of the information from that horse diagram. Now, you can see I have an L1 and an L2, the list information that has the points that I was collecting. Now, I didn't collect very many points. This is what's known as sampling when you're considering taking points off of a full set of data. If you have a lot more points, you're going to have a lot better of a process. Now, if we recall that horse picture had like a bump and then another bump. It kind of went down and up. So that's going to tell us a little bit about which equation to try to use. So we'll go stat, and we're going to go to where we would normally see regression. Now, linear regression would give us a line that goes through those points the best. Because we know there are curves, we don't want to use linear regression. Quadratic regression will give us a quadratic, and the best fitting quadratic that goes through that data. But a quadratic only has kind of one bump. So because there's more than one bump, we're going to use a higher degree polynomial. We could use a cubic. A cubic can make like an S shape, or we can use a quartic. A quartic can make like an M shape. You can do other types of regression as well, but on our calculators, the quartic regression is the highest that we get. Now, if you wanted to model the outside of like a non-concave shape, like, I don't know, a scoop of ice cream or something like that, that maybe is just round, you could get away with either quadratic, cubic, or quartic. But we'll use quartic regression. Now, I'm going to use my mode here, and I'm going to change my stat diagnostics to on. It's going to give me a little bit more confidence in my final answer, because I'll be able to know an R value. So quartic regression, my list 1 is my X values, my list 2 is my Y values. I don't have a frequency list, and I'm also not going to store the equation. I'm just going to write it down here. And I go forward and do it, and it gives me these numbers. And it even tells me, hey, my R squared is pretty good. So this actually is going to have a pretty close fit. Now, these numbers are all to the power -7. So this is -1.97 times 10 to the -7 x to the power 4, because it's your A value. So the y-intercept of this is -369.42. And the term that goes with just x is 13.84319 blah, 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 x. Okay. So that should get us to our next point. I'm going to enter all this information, and I'm also going to enter in some other information into Desmos so we can see that picture of the horse's back and how close this curve gets us.